60 reads, what is cosine of pi 12s given that pi 12s equals pi thirds minus pi fourths, and that cosine of alpha minus beta equals cosine of alpha times cosine of beta plus sine of alpha times sine of beta. Then we have a table with angle measurements and then the sine of that angle and the cosine of that angle. The very first thing that we need to understand about this prompt is remember that angles can be given in either degrees or radians. There are other units, but right now we're just going to stick to these two, which is what the ACT focuses on. So how do we know if an angle measurement is in degrees? Well, there's two ways. One, it could specifically say the angle is in degrees, but really, watch what's happening here. Let me write some angles that are in degrees. Let me rewrite that, I'm sorry. Okay. Confused? Well, don't be. Look at this little circle here on the above the where the actual number is written. That tells you it's a superscript. That tells you that it's a degree. If you look at this one, you may be confused of it and say, wait a second, I usually see pi in radians. Why would this be a degree then? Then you'd be making a very big mistake in terms of what pi is. Pi is just a number. So I can perfectly measure pi in degrees. So if I have a protractor, I can try to find the angle 3.1415926, etc. in degrees. And it would be a very, very, very small angle, a tiny, tiny angle. But at the end of the day, that is pi degrees. Pi 6 would be even smaller because you'd be dividing that into six equal pieces, so imagine. But at the end of the day, it's perfectly valid to talk about pi 6. So don't think that just because an angle measurement contains pi, it's automatically a radian. Be very careful with that assumption. If the number contains the symbol, the little circle here in the superscript, then it corresponds to a degree measurement. And degrees, as you know, a full circle is 360, etc. Now radians, let me show you some radian angles. So yeah, the pi halves could be 1, pi fourths, but so is a 2. Now, and I could even, let me give you another example here. I can do this one, 45. Now, I know that you typically associate 45 with a 45-degree measurement, right? But it doesn't mean I can't have 45 radians. And I don't need to write radians. If I'm doing problems and using angle measurements, and I've already said that I'd be using radians, then I can say the angle is 45, and you should know it's in radians, okay? So in this prompt specifically, I really don't like the fact that the ACT people in a prompt like this one do not specify that the angles are in radians. I honestly don't like that because at the end of the day, it should be explicitly stated. But there is something else. I mean, you're supposed to know that, for example, if the angle is equal to pi sixth and sine of the angle is equal to 1/2, which is simply 0.5, you're supposed to know that that is actually a measurement in radians. And the reason why you're supposed to know that is because you're supposed to know what angle gives you a sine of 0.5. And I don't know if you know that, but it's something that you should probably memorize. A sine of 30 degrees is equal to 0.5. So if you see the table here and you see that the sine is 1/2, and yet the angle for that 1/2 is pi sixth, not 30 degrees, then you know that these angles are in radians. I hope that I'm able to, clarify that for you, because it's very, very important that when you're taking the ACT, that you're able to understand or identify when the angles are in degrees and when they are in radians, so that you can set your calculator to the correct mode. One of the methods of solving this prompt involves using the calculator, and I explained that at the end of this video. So just make sure that you can, again, identify when the angles are given. Now, I did explain, the fact that these angles are in radians, and strictly speaking, it's not necessary if you solve this prompt the way it's meant to be solved using algebra, but it is important for you to always identify when angles are given in radians or in degrees. There is a second method you can use to solve this prompt. It'll be explained at the end of this video using the calculator, and for that you definitely need to know that these are radians. So it was worth reviewing that. But now let's try to solve this prompt the way it was intended to be solved. First, realize that they want us to figure out what cosine of pi 12 is equal to. And again, it's cosine of pi 12 radians. Please remember that. Okay, so how do we find cosine of pi 12? Well, given that they give us cosine of, say, pi sixths, pi fourths, and pi thirds, we really couldn't determine that. However, they did tell us that pi 12 is also equal to pi thirds minus pi fourths. And then I see a table here with angles and then the sine and cosine of pi thirds and pi fourths. So that's probably going to be helpful. Finally, I see this relationship given to us, the fact that cosine of alpha minus beta, when you're subtracting two angles, is equal to cosine of alpha times cosine of beta plus sine of alpha times sine of beta. This is a trig identity, and you don't need to know it by memory. They're giving it to you so that you can use it. So watch how you can use algebra to figure this one out. Because we want to know what cosine of pi 12 is equal to, but we have no way of determining that from the information given, we need to replace pi 12s with the sum, or the subtraction in this case, of pi thirds minus pi fourths. So we're after cosine of pi 12s, but expressed as cosine of pi thirds minus pi fourths. Remember, this is pi 12s at the end of the day, so we are finding cosine of pi 12s. We're just using this equivalence, because then we'll be able to use this trig identity to figure it out. Okay? Well, according to this identity, it's going to be equal to cosine of alpha times cosine of beta. So who's alpha and who's beta? Well, just put the identity below and then it'll be perfectly clear. Alpha is pi thirds, beta is pi fourths. So when I see cosine of alpha times cosine of beta, I should write cosine of alpha, pi thirds, and then times cosine of beta, which is pi fourths. I'm again using this part of the identity. Now plus sine of alpha times sine of beta. So that would be sine of, again, alpha is pi thirds, so pi thirds times sine of beta, which is pi fourths. There you go. Now if you're wondering, well, why is that going to be helpful? It's going to be extremely helpful because we know what cosine of pi thirds is equal to. Cosine of pi thirds is equal to 1/2. We know what cosine of pi fourths is. Cosine of pi fourths is square root of 2/2. We know what sine of pi thirds is. Sine of pi thirds is square root of 3 divided by 2. And sine of pi fourths is square root of 2 divided by 2. So we replace that. We say, okay, cosine of pi thirds minus pi fourths, which we know is equivalent to cosine of pi 12s, okay, is equal to cosine of pi thirds, that's 1/2. So let me put that here, 1/2 times cosine of pi fourths, which is square root of 2 divided by 2. And then plus, now sine of pi thirds is square root of 3 divided by 2 times sine of pi fourths, which is square root of 2 divided by 2. Looks very confusing, but at the end of the day, now all I need to do is clean it up and find the correct answer. Watch. How much is 1/2 times square root of 2 divided by 2? Well, when you have fractions multiplying, they're easy to multiply. You just multiply straight across. So this is going to be equal to 1 times the square root of 2 is simply the square root of 2 divided by 2 times 2, which is 4. Plus, And then square root of 3 times the square root of 2 is the square root of 6. If you're wondering where that's coming from, well, there's a property of roots that says, say, think of this one. This is a very common root. The square root of 36. You know that's equal to 6, right? Okay. The square root of 6 can also be written, of 36 can also be written as the square root of 9 times 4. Think about it. How much is 9 times 4? 36. Well, what this property says is that you can actually split this into this. Whenever you have the root of two numbers multiplying, you can say it's equivalent to the root of each of the numbers and multiplying. This is a principle of roots. And I'm going to prove that to you with this square root of 36. What is the square root of 9? It's 3. What's the square root of 4? It's 2. And 3 times 2 is 6. And the square root of 36, we already said, was 6. So this does, in fact, work out. So what I did at this stage of the prompt, when I had to multiply the square root of 3 times the square root of 2, I could have left it as the square root of 3 times the square root of 2 like this. But notice how in your choices here, there's a square root of 6 in a couple of them. And that's because when you multiply the square root of 3 times the square root of 2, you can actually combine those two numbers into a single root by doing the square root of 3 times 2, which leads to the square root of 6, which is what I wrote. Okay, so now that we've done this part, we then divide by 2 times 2, which is, again, 4. Now, we have two fractions adding, and fortunately for us, they both have the same denominator, so we can just add straight across. Square root of 2 plus square root of 6 on the numerator. And then everything divided by the 4, which is the common denominator, the denominator of both of these fractions. Now, I know that when you see this answer and you try to match it with those given, well, f is wrong, g is wrong, and then j doesn't even have the square root of 6. So it's really between h and k. Well, k doesn't work because it's square root of 6 plus 2, and where did that come from? So that's wrong. It's h. If you're wondering why the numerator contains the square root of 6 first, well, if you're adding, say, a plus b, that's the same as adding b plus a. So it doesn't matter if I switch the order here and write the square root of 6 first. And typically, when you're simplifying and writing mathematical expressions, if you have terms like this with roots that are irrational, that cannot be simplified, you typically start with a term that contains the highest root, in this case the square root of 6. So they just rearranged it and presented the answer in that format. So choice H is correct. It seems like a lot of, there's a lot of things going on. Notice how we didn't even need to know that the angles were in radians, but it's nice to know just to keep that in mind. Now the next method we're going to see on the calculator involves using the calculator, but it can take you a little bit of time to find the answer that way. So if your algebra skills are strong, this is really the method that you would want to use to solve it. But let's check out the... Careful with 60. If you have your calculator set to degrees and you try to find the cosine of pi 12s, so you do cosine and then just enter second pi divided by 12 like this, cosine of pi 12s, you're not actually finding the cosine of pi 12s. You're finding the cosine of pi 12's degrees, and this is an angle in radians because it's in terms of pi. Be very, very careful with that. So you would need to go to to mode, and then go to radian degree, switch it to radian mode. Now that it's in radian mode, you clear everything. Look what happens when you press cosine, and now do the second, the pi 12s, like this. You get a different value, 0.9659, etc. And the reason, again, is because we're using radians now, which, this is expressed in terms of radians, not angle, not degrees. Now, they want us to know what is cosine of pi 12s. There you go. There's your answer.
The problem is that all of the choices are not in this form. They're, for example, F reads 1/4, 1/4. Well, clearly F doesn't work. G is 1/2, 0.5. That clearly doesn't work. Then we have H, J, and K. What you could do here is simply enter that. Parentheses for H, for the numerator, square root of 6. Square root of 6. And then get out of the square root, plus square root of 2, close. And you see the problem if you don't get out of the root, so delete that, sorry, get out, close the parentheses. And then it's divided by 4. Well, we get 0.96592, blah, 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 the exact same answer of cosine of pi 12. That means that H is correct. But again, if you had done this cosine of pi 12 with your mode, remember you go to mode, with the mode in degrees instead of radians, you wouldn't have been able to figure this out. You would have gotten the wrong answer because you would have said, wait, that doesn't work. I'm looking for 0.9999, etc. But no, this is cosine of pi 12 degrees. And again, they're giving you an angle in radians.